colleague of mine, but he's a friend. He's a member of the Explorers Club, as am I, and I'm also a member of the Adventures Club. My name is Steve Elkins. So, it's a really interesting program. Lewis is really an iconic and legendary person in the space program in the United States, in fact, in the world. He's been doing it for what, about 60 years now? Or 55 years?
That's what makes you a legend.
Right. No, but you've done some incredible things, and it would take probably several days to talk about everything he's done. But we're here really to talk about his book, Planetary Adventures, Together to Mars, which is quite an amazing story. I was pretty impressed when I read it, and I talked to Lou about it. So here we go, Lou. What is this project, your introduction, Pursuing Mars? How did it all get started?
Well, it was interesting. We formed the Planetary Society in 1980. It's a very different time than it is now. The U.S. had actually decided to quit planetary exploration. In the 1960s and 70s, there had been NASA missions to Mars and Venus, and they had launched the Voyager missions to the outer planets. But in the 1980 administration, the incoming administration decided there was going to be no more planetary exploration for at least a decade. And this was something that we thought we had to change. And so that's when Carl Sagan and Bruce Murray got together and said, we need to form a public interest organization, something that, you know, what do you do when you don't like what the government is doing? You form an interest organization and you try to change it. And so they got together with me. I had been working at JPL. I had spent 2 years back in Washington as a Congressional Science Fellow, and so I was coming back to JPL, so I was a target of opportunity for them to take and form this new organization. So very quickly we got into advocating planetary missions, of course. We wanted, there was a number of ones, including going to Halley's Comet, which several other countries were planning to go to, but the U.S. was not. And so this was a strange time. The U.S. did not have much of a space program. They were going to build a shuttle, but they were going to stop the science missions. They were going to stop exploration. And at the same time, Russia had a very active space program. They had done missions to Venus. They were building Mars rovers. They were planning a mission to Halley's Comet, and they actually had a space station orbiting at the time. Sort of the opposite of the way it is now. Russia was doing a very active space program and carrying on. So our whole objective in making this outreach to get involved with the Russians and work together with them wasn't because we were pro-communist. Remember, this was the time of the Soviet Union, or because we loved Russians, even though there are a few here in the audience that I do love, or any of the more altruistic reasons. It was because we were advocating planetary missions, and this was a way to keep the American scientists and American engineers involved if we could work on going to Mars together.
It's actually pretty interesting that you were able to pull this off in, what, 1984 you started this?
Yeah, it was 1983, so it was the height of the Soviet Union. In fact, my first trip to the Soviet Union, I landed there on the night that Andropov answered Reagan's Evil Empire speech. And the relations were as frosty that time in 1983 as they are today. But as you know, quickly that era passed, and then a lot of things have changed, and that's what we'll get into as I describe how we started doing small things and big things, and that's what I think is going to be the theme tonight, is that we did small research projects like a Mars balloon, which started out as a research activity with students at Caltech, and then quickly became part of the Soviet-French planning for doing a Mars mission, and at the same time did large conferences that involved the two countries that ended up getting the idea of a human Mars mission put on the Reagan-Gorbachev summit agenda. So we were working at both levels, one the very research level of activities, and the other the policy level of trying to bring the countries together on a peaceful goal to explore another world.
It's rather interesting, I never really thought about this myself, that really science sort of overcame the politics of the era, and the scientists got together for a common cause, and you were able to pull this off. To me, it's rather amazing. I mean, I think in the beginning, if I'm looking at my notes correctly, they were celebrating the 30th anniversary of Sputnik when you started this?
Well, the 30th anniversary of Sputnik, that was 1987, so that's already a few years into the story. But yes, the U.S. had a policy of not dealing with the Russians at that time, and there was the space agreement of cooperation, which had existed in the 1970s, had lapsed. So there was no official contacts. But we had formed some close association with Russian space scientists. It started out in 1984. We had organized a meeting. We got people together informally as a nonprofit public membership organization with no government support. We could do that, but we got a lot of people to attend. And then in 1987, during the Soviet scientists got approval to do a 30th anniversary celebration, but they needed to invite a lot of Americans there. They wanted to invite the Apollo astronauts. So they came to me and they said, how do we do this? We don't know how to we have no mechanisms to do the official invitation. They couldn't work through NASA, they couldn't work through the government. So we had something at that time in 1987, maybe some of you have heard it, it's called email. And it was just getting started. And so I said, look, I'll send out a lot of email invitations if I can do it in your name. This was Dr. Raul Sagdayev, who was the head of space science in Russia. It'll look like it came from you, and you'll get invited, and we'll invite all these Apollo astronauts. They were going to pay the way and go. So I did that, and we ended up with about 12 of them coming over, and including, we had a group of about 50 Americans, including some officials, actually, that ended up coming. And that was a big celebration of the 30th anniversary of the space age. And that led the way to some of the activities that I'll be talking about.
Well, didn't that lead to the Together to Mars?
Yeah, we did we did something called the Space Bridge. Live TV in the big pavilion in Moscow, and live TV at the University of Colorado here in America. We had some astronauts. We had the former administrator of NASA, Tom Paine, of course, Carl Sagan. Buzz Aldrin was on our panel. On the Soviet side, they had several cosmonauts and science fiction writers and scientists involved, and they were discussing ways to do robotic and human exploration of Mars. The New York Times this was all filmed on a live television activity in the two countries, and then it was made into a PBS show, which was shown on Nova, actually. And the New York Times interview said, what was remarkable about this event was not so much the content, but that it even worked. That the idea that you could have a TV conversation, remember this was before the internet, it was when you couldn't even make a telephone call to Russia without going through operators. So it was quite remarkable that we pulled that off, and it did pave the way to bring Mars in a much higher level of attention, so much so that in the following year, 1988, when Gorbachev and Reagan had one of their summits, on the summit agenda was the idea of a joint human mission to Mars. It failed to make it through the agenda and onto as an approval. It kind of, in the negotiations related to the U.S. Strategic Defense Initiative, Star Wars, each side had something they didn't want to give up. Both sides overestimated the capability of the Strategic Defense Initiative, and they wouldn't give up their position on that. So the Mars initiative at that time didn't happen, but a lot of other initiatives that did have us working on Mars together did occur afterwards.
Well, speaking of initiatives, wasn't that the time you mentioned that you and your colleagues came up, I guess the Soviets and yourself, about flying hot air balloons on Mars?
Yes, yeah.
So,
yeah,
sounds crazy now, but that was the beginning of how they would eventually survey Mars. So that happened in what, 1988?
Well, no, we actually, well, yes, we did the testing in Lithuania in 1988.
Soviet Lithuania.
Soviet Lithuania. But this, it started as an activity in the earlier 80s as a student project at Caltech that I mentioned. Bruce Murray was the faculty member at Caltech who became the director of JPL, and he had a group of students working on this. And Jacques Lamont, a chief scientist in the French Space Agency, was an advisor to JPL, and the French had already had experience with the Russians doing a Venus balloon. So ideas began to flow back and forth, and a group of our students and some of our volunteer engineers working with the Planetary Society invented a concept called the snake. It was really a guide rope on the balloon. Those of you familiar with ballooning, you know, you carry a guide rope, which serves as a kind of a ballast. If the guide rope hits the ground, the balloon will stay aloft because it unloads weight from the buoyancy of the balloon. When the balloon then, it's a hot air balloon, so when the balloon heats up, either through, if you're injecting heat into it, or if you have a hot air enclosed balloon which heated by sunlight, then it gets enough buoyancy, it pulls the guide rope up. Well, we came up with this concept for using the guide rope to on Mars, and then instrumenting the guide rope with science instruments so that they can measure things on the surface. It's really a novel idea, and it was really an invention that we had come up with. But the French were very impressed with it, as were the Soviet scientists, and they ended up incorporating it into their development program. But we had to prove it out on a lot of testing. So we came up with various kinds of tests, including us humans getting in the balloon and flying. I guess we could go to the next slide. Is it up there? Yes. Okay. And so we have, we did tests we went to Lithuania and we did tests there with instruments hanging down from the balloon, us then supplying the heat in the balloon. Wasn't the same kind of balloon, of course, that would be used robotically on Mars. However, there is one story I'll tell you, which is we were flying in the balloon and we were supposedly restricted to an airfield. We couldn't go out of the boundaries. I mean, this was the Soviet Union. It was militarily controlled, and we were restricted, but we're up in the balloon, and we took off. And as we go over the fence and the boundary, they're yelling at us. But we didn't stop. There was a river, which you see in one of the pictures there. We went across the river, which we knew was about 30 miles from the nearest bridge. So we knew that as soon as we landed, we had a good hour, a couple of hours before anybody would come and get us. And we did land, and we landed in a field where there was a cow and some woman tending the cow and her grandson. And so I went over because everybody else was busy packing up the balloon, and I was supposedly in charge because it was a Planetary Society thing. So, and I thought I knew some Russian, so I went over and I started to explain that we were out testing Mars balloons for Russian and American scientists who wanted to do a mission to Mars. And the little boy, thought that was interesting. He talked to his grandmother, and then we all went off, and she gave us some little snacks while we were waiting. And then when the rest of the crew caught up to us and came over, one of my Russian friends came over and said, "What did you tell those people?" And I said, "Well, I tried to explain why we were here." He said, "Oh, they thought you said that you had just landed from Mars." I like that story because they accepted it. It was all right. And, that's what we wanted to have happen.
And of course, it's strange, at least to me and perhaps to you, to think of using a hot air balloon on Mars. And actually, I asked Lou the other day when we were talking about this, well, I understand that Mars often has very high velocity winds. So if you had a balloon, how are you going to control it? But then he explained the density of the atmosphere in Mars is so thin that there's not enough mass to really move stuff very fast. Even though the wind could be 100 miles an hour, it doesn't have enough, I guess, inertia.
There's not a lot of force there.
Yeah.
So then we invited the French group who was working on the balloon to actually come with their actual balloon, the kind that would fly on Mars, which is a thin enclosed balloon, and test the snake idea. And we brought that to the Mojave Desert and did a number of tests out here with that. And we found some problems. I mean, the snake, as you might suspect, gets snagged in rocks in time. And it wasn't altogether suitable for carrying the instruments. At the same time, the Soviets were getting much more interested in rovers. Remember, the Soviets had done an automatic lunar rover in 1972, right after we did the human landing on the moon. They never did a human landing on the moon, but they did robotic landings on the moon, and they did a robotic rover on the moon, and they did a robotic sample return from the moon. These are things the U.S. never did and has still never done. So they had a tradition of these lunicods. The work on the lunicod was developed by a remarkable guy, Alexander Kermer-Jean, who was a survivor of the siege of Leningrad. And then he stayed there, and he was the head of a Soviet tank factory that was building tanks during the whole Cold War period. But as the space age came along, they converted that into the place where the lunicod was developed. And now he was developing Marsicods. So we went to Leningrad and went to his factory and learned about Mars rovers. Remember, U.S. had no rover program at this time at all. In fact, the American science community was actually opposed to rovers. They thought they were kind of a stunt. They took up too much weight away from science instruments. So we didn't have any rover development going on. So we were trying to promote rover development here in the U.S. So we brought together some volunteers, ex-JPL people, other aerospace people, and started a test program. And the Soviets invited us to go to Kamchatka, where we did rover testing, and we invited them to come to Death Valley, where we did more rover testing and did rover demonstrations here in the U.S. And I think that led in a major way to getting rovers accepted in the U.S. program. But I'm probably running ahead of the story.
Well, you did a little bit because you had
I realize now I got wound up, and I'm sorry.
It's all right. It's a good story. You had another, you had a camping trip where you had another balloon trip
Right.
involved
Well,
that happened before the rovers.
that's right.
It was a second try.
As part of the ballooning, we decided that we'd do a number of hot air balloon demonstrations in Russia, and we would also use it as an opportunity to test instruments that we could drop on the ground. But this was going to be done in an area outside of Moscow, and then also in Ukraine, in Kiev. My wife and I, by this time, I had become quite friendly with with a lot of Soviet scientists, and in particular, I had a very good friend. And so my wife and I decided, why don't we go camping with them, and then we'll meet up with the ballooning group once we get to Moscow. So we rented a car in Berlin, drove through Poland, drove through East Berlin, drove through Poland. Again, this is Soviet times. Drove through Brest into Belarus and met our friends in Minsk. And then we did a camping trip. And this, you could tell this was sort of a changing time. This was Soviet times, but it was also the glasnost era, the perestroika era of Gorbachev. And they were opening up and they were welcoming visitors in a way that they hadn't before. But it was also a very difficult time. We rented a car that was diesel because the gas lines in Russia were so long that the only way we could get gas for our car, we thought, was to have a diesel and get in front of the trucks and bribe the truck drivers to let us in the line early. And it worked out. And so the trip was very successful. We did fly the hot air balloons in Moscow and at the VDNK, the big Soviet space or exhibition pavilion in Moscow. Then we flew it in Suzdal, and then we drove to Kiev and flew demonstration balloons there, and then we drove it back out and and did more hot air ballooning demonstrations. The tests, as I say, they had mixed results. And by that point, attention was beginning to shift into rovers as the way to explore the surface.
But shortly after that, in '91, you said you had to sweat out a coup in Kamchatka.
Yes, and so then, as I say, the Soviets invited us to go to Kamchatka, where they had a month-long, in fact, I think a 6-week-long campaign, where they brought the rovers to the. Kamchatka is the most volcanic region on Earth. It's just a continuous string of volcanoes, and they had a region on Tobolchek, volcano region there, where they did a lot of the rover testing. You'll see that in one of the pictures there. You see the camp and a big volcanic area. So they invited us to go there, and so 4 of us went. One was actually a JPL employee who took leave because it was an unofficial trip, and then one was a former deputy director or associate director of JPL who is now retired, volunteer, remarkable guy, the project manager of Voyager and Galileo in his day, and then 2 other, both aerospace engineering background. We went over, so we're going to fly from LA to Anchorage, and then from Anchorage to Khabarovsk in Siberia, and then from Khabarovsk to Petropavlovsk in Kamchatka. So we get to Anchorage, and of course, we're milling around the airport. One of the guys says, "Oh, I'm going to call my wife and say goodbye," so he calls his wife. And she says, "Don't go. Don't go. There's been a coup in Russia, and you don't want to get there now. The military has taken over." And he comes back and tells us this, and we think he's joking. No. Well, we all call our wives. We all find out it's true. And at that moment, the flight attendant comes out and says, "We're leaving in 3 minutes. Get on the plane or stay here." We had no choice.
And this is an Aeroflot plane, a Russian plane.
We're an Aeroflot. We're flying from Anchorage to Khabarovsk. So we have a quick 1-minute discussion. We decided we're going to go. So we get on the plane. It's an adventure, right? That's why I'm here.
And it's off the beaten path.
Yeah, really. I mean, what are we going to do? Get on the plane and come home? So we get on the plane. We land in Khabarovsk, and we're met by our Russian colleagues, including Alexander Karmazhan. And they say, "Well, the connecting flight, we can't take it because all flights in Soviet Union are grounded. Nobody's flying anywhere. So we have to stay here in Khabarovsk." Well, Khabarovsk is a little town. It's on the Amur River, which borders China. And we couldn't get a hotel in the town. Everybody was sort of stuck, and there was no way to get a hotel. But we're VIPs. We're Americans. So they took a room in the airport and let us sleep on the benches. Didn't let any other people in there. So we got our own bench to sleep on in the airport. But we couldn't get there till midnight because the airport was being used. So we had to drive around in Khabarovsk for a couple of hours to kill time. So we drove to the Amur River, looked at China and said, things are crazy in this country. Maybe it's better to swim over there and take our chances that way. But we didn't. We did sleep in the airport. The next morning, they did have a plane that was going to Petropavlovsk. We landed in Petropavlovsk. We immediately went to the beach there where it goes out to the Pacific Ocean. Again, wondered whether we should be going across the Pacific Ocean back home, but we stayed there. And you'll see in one of the pictures, the actual place we had to go to was about a 14-hour drive from Petropavlovsk. And so they had these big trucks and buses to move our equipment and to move us. We got stuck in a river and we had to push the bus out. But we got to the town of Kaunas. I'm blank on the name of the town. A little town in central Kamchatka near the volcanic region there. Mosquitoes were terrible. But, and we went in, we got our bedrooms and set up and everything, and then we went down and watched television. And it was that famous press conference was going on in Moscow where the coup leaders were telling how they were going to restore law and order to Russia. And, but we didn't know it at the time. 3 of the 4 of them were drunk. But Kermashon, who is this veteran of the siege of Leningrad and on the whole Second World War and worked with the Soviet military, he took one look at the television and he got up. I'll never forget this. And he goes, "Dilettantes," and he walks out of the room. And we knew that coup was going to not work. And sure enough, within a day, it didn't work. And Gorbachev was restored. Ultimately, that same year, the end of that year, the Soviet Union collapsed. But that's what I meant about playing on the international scene in the big picture. And meanwhile, the next day, we got up and went to the volcano regions and climbed up to Balchik and went to do the rover testing. The reason they had a 6-week campaign was because many days you have rainy weather or bad weather there, and so out of 6 weeks you might get 4 or 5 days of testing, is the way they described it. So at the end of our test period, which we had, I think, only 2 days of testing out of the 6 we were there, we invited them. We said, well, why don't next year you come to America and you can bring the rovers and we'll do the tests in America in the Mojave Desert. In fact, we'll get a permit and we'll do it in Death Valley. And they said, okay, yeah, that'd be great. They said, well, we'll plan a 1-week trip. And they laughed. They said, we can't do it in a week. You never know how many days you get. I said, we know the weather in Death Valley. It's not going to rain. We guarantee it. And sure enough, they came the next year, and you'll see some pictures of the Death Valley test. The park officials were very cooperative. They cordoned off an area which ultimately got named Mars Hill. We did the test there. We did tests in Dumont Dunes, which is not in Death Valley, but nearby with the rovers. We tested the rover under many conditions. We not only got done in the allotted 6 days, we got done in 5 days. And so as a reward, we took our entire Soviet team, which was about 11 scientists, and we had a crew of about 20. We all went to Las Vegas for the night. I gave each of the Russians $25, and I said, just be sure you're out here in the parking lot at 8 o'clock tomorrow morning. And it worked.
Well, interestingly, around the same time, I guess your group as well as the Russian group started becoming concerned about the Earth being destroyed by a wayward asteroid, the Armageddon syndrome. And you have a picture coming up here with Edward Teller with his hands on a giant atomic bomb.
Hydrogen bomb.
Hydrogen bomb to be used to blow
The biggest
up.
one ever made.
Okay, you
That's
tell the story.
Soviet big hydrogen bomb. They called it 100 megatons. It was really only about 65, but it was huge. And Teller, of course, is the father of the hydrogen bomb. He's a very well-known American scientist, controversial scientist for many reasons, including his dispute with Oppenheimer. For those of you who saw the movie, you saw Edward Teller portrayed in the movie. Teller was at Livermore, and the Livermore science team there was working on ideas for how to blow up an asteroid or how to mitigate against a possible asteroid that might be coming close to the Earth. Well, this is now 1994. Soviet Union has ended, remember, it ended in the end of 1991. So this is now Russia, and the Russian Cold War nuclear scientists are basically out of a job, just like so many others of those who were working on the whole concept of mutual assured destruction. One thing I learned, which was surprising to me, they were all idealists. They believed they had saved the Earth by this policy of mutual assured destruction. They certainly had prevented a nuclear war, and that is a result they were very proud of. And at the end of the Cold War, they had that same idealism that they wanted to channel in other directions, and the idea of protecting the Earth from an incoming asteroid, you can't get much more idealistic than that. So they were very highly motivated with applying their capabilities for mutual assured destruction to the destruction of an asteroid, or the mitigation against near-Earth asteroids. So they invited a number of people to a conference, including, I think we had one NASA scientist. Again, it was unofficial, so we couldn't have an official delegation there. But Edward Teller and one other Livermore scientist was part of it. Planetary Society helped sponsor American scientists' participation so that we could go. So we had 5 scientists, including some from NASA, who we sponsored, and I went. And it was a surreal scene to go on this adventure, if you will, to a little-known city near Ekaterinburg, east of the Urals. The city is called Chelyabinsk 70. It was so secret it wasn't even marked on the Russian maps. It was the equivalent of our Los Alamos, where they had done all the nuclear bomb development. And it was a nuclear, in that sense, a nuclear scientist city. So we went there at their invitation, had a very good conference. Teller was treated like he's honored, the father of the hydrogen bomb, being at the site where they were building hydrogen bombs. And of course, this was a period where we were having good relations with Russia, and everybody wanted to work together. So he was treated with a great deal of honor, and that's where that picture was taken. Imagine my surprise when a young man came up to me one day at breakfast and said he would like to invite me to go to the school, the town. They had a lot of school kids in the town because it was a place where the families lived also, families of the scientists, and go to their library and give a little talk about Planetary Society. So I said, of course, I'll go. So I went. Imagine my surprise when I go into the library and there's a whole Planetary Society billboard displays with our magazines out there and everything. They were all members. They had joined, and so they kind of knew me at that point, and it was interesting. But they were all, as I say, motivated by this idea. That conference lived on for a number of years throughout the 90s, and there was some work developed. Most of the attention is not on the idea of destroying a near-Earth asteroid with a nuclear weapon, because you'll fear of breaking it into fragments, and those fragments would rain upon the Earth just as deadly as the asteroid itself. And the idea is more focused on moving the asteroid, either kinetically by bumping into it. There's been some space missions now which have tested that, or by doing something with lasers and trying to ablate material and move material and other ideas. Those will all work if you have a lot of time, warning time, that an asteroid's coming to Earth. But if you don't have a lot of warning time, there's no other solution except to nuke it.
Then you have to call Bruce Willis.
Right.
And he has to go blow it up, right? You also mentioned that you got lost in a place, if I pronounced it right, Baikonur?
Baikonur. Well, I didn't get lost there. The lost refers to, we lost a spacecraft there. The Mars 96 mission, which had started out as the Mars 94 mission, which was the original mission that we had hoped to fly the balloon on first. And then when that went away, then we hoped to fly the Mars rover, the Marsicod, on that. And we were working closely to, by this point, getting rovers into the American program as well. Well, by that point, the Soviet Union was ending, and their support for space science was ending. So they had to give up not only on the balloon, they gave up on their rover as well. But the Mars 96 mission still flew, still was planned for launch. It had 2 small landers on it, small stations they called them, no bigger. They would have fit easily on the 2 of them, both of them here in the chairs that we're sitting in. And they were going to be, and then they had the lander that was delivering them to Mars as part of this mission. And it was being launched on a Proton. So you see here the Proton rocket, and it's launching the spacecraft. And we were all there for that. We were invited to the launch because we were quote, part of the mission team. We had a little payload on it, which I'll describe later here. And we saw the launch. We thought it was successful. We actually had a dinner with, toasting, as you do in Russia all the time, toasting with vodka, the success of the launch. And then we had about 3 or 4 hours sleep before we had to catch a flight back to Moscow. But in 3 hours when we woke up, we stepped out of our room and we looked at the Russian scientists and we knew something was wrong. They were all dour and sour, sad-faced. Spacecraft had been lost. And the Mars 96 mission, the stage, the Proton, did fail to put it into orbit. And in fact, there was a whole story going on that we knew nothing about at that time, that our military, the U.S. military, was tracking that launch, and they saw that it was coming back to Earth, and they calculated that it might have a chance of hitting Australia. So they called the Australians, woke up the Prime Minister and said, watch out, cover your heads. There's something may be falling down there. Well, it turns out our military wasn't as good as they thought they were. They were tracking the wrong object. And the actual object that was coming back down was missing Australia entirely. It was the payload, and it ended up in the Pacific Ocean, actually quite far to the east, almost to the South American border, but it did land in the Pacific Ocean. But there was still a lot of concern about this because they had these small landers on them, and they were powered by plutonium, radioisotope heating units, small amount of plutonium, not a reactor, but just the decay heat of the plutonium was providing the heat for these landers. And everybody wanted to know, including people at NASA, how much plutonium was on it, including our military, and they had no information on it. Well, we got back to Moscow, and you see me with my friend Slava Lincoln. We were drinking fairly heavily after this failed launch. So we were drinking first, toasting victory, and then toasting the loss. And so we were back in his apartment, and I decided I'd better call my friend at NASA, the administrator, Dan Golden, and kind of give him what was happening over here. And he said, "Oh, good, you're over there. That's great. We've been trying to find out. Do you know anybody who knows anything about those landers and the plutonium on them?" I said, "Well, it just so happens I'm in the apartment with the chief scientist of the Mars lander. He knows all about it. He's the one who put the plutonium on the lander." So he immediately got on the phone, and Golden immediately patched him into the Pentagon. So there we are in the Russian apartment with our champagne, and Slava Lincoln is talking to somebody in the Pentagon, I don't know who, about, "Oh yeah, it's this many grams. No, I can't do this. No, it's okay. It's shielded like that." And it's got in a little container, and he's given the size and everything like that, just passing along the information as if it was unclassified, which it was in a way. But so we did do something good out of that, but it was a terrible loss. Soviets and the Russians have never had a successful Mars mission. This was to be it. They didn't, and this was their last attempt at one in all these years, and so it's been a long time.
What happened in Murmansk a few years later?
We were 2 years after all of this. Russians proposed to us that they could help us develop a solar sail, something the Planetary Society had been interested in for a number of years. And they would provide a free launch and even an inflatable booms that could deploy the sail if we would supply the sail material, and then we'd help develop the spacecraft, and they would build the spacecraft.
Maybe you want to explain what a solar sail is.
A solar sail is a large, it's a sail, but instead of catching the wind, an ordinary sailboat, I don't have to tell you all, operates on the interface of wind and water. You have a rudder which steers it in the water, and the wind provides the propulsive force, and you steer it with the rudder. The solar sail operates with a propulsive force from the solar photon flux, not the solar wind. That's a smaller force. But it's the light energy from the sun, the photons, hit the sail, bounce off, and that provides a propulsive force. And the rudder, if you will, there is no rudder, but the analogy to the interface is gravity. You're always changing the orbital speed. And if you tilt the sail in one direction, you can add orbital speed, and if you tilt the sail in the other direction, you can subtract orbital speed. When you subtract orbital speed, you fall in toward the sun. When you add orbital speed, you go out into the solar system. So that's how you steer it. So we were developing this concept as a low-cost means of flying into the solar system, so we wanted to, Soviets, or the Russians at this point, were going to do that. They offered us a free launch for testing the deployment. Well, there's no such thing as a free launch, and that's what we learned. It diverted us for a couple of years. We built a test apparatus. We had a deployment of a single sail. We went and bought cameras at Best Buy and took them over to Russia, and they took them apart and integrated them into the spacecraft. My son-in-law is working with Best Buy, so that's why I had to give that plug. And then the deployment launch failed, and it was supposed to do a suborbital flight to land in Kamchatka. It did land in Kamchatka, but they never found it. And so we never recovered the film that was going to be, or the video recording that we had hoped to have. So this is me being invited onto a Russian Navy ship to observe the launch out of Murmansk in the Barents Sea. And sure enough, we observed a submarine launch. It looked like a good launch, but we learned pretty quickly that it wasn't recovered. I was on the phone kind of giving a live update summary to my colleagues back at the Planetary Society. And then 3 years later, we built the actual spacecraft, the actual solar sail spacecraft. We got it all done, and it also was launched on a submarine-launched ballistic missile, and it also failed on launch. And there's a whole story, which I don't think we have time to get into, about my feelings about the Russian Navy and the Russian submarine-launched ballistic missiles. But that launch also failed, and that's why I say there's no such thing as a free launch.
Well, you also did something which I thought was quite remarkable, the whole team. You had this Visions of Mars, setting up the first library on Mars. Maybe you can explain to the audience what this all involved.
In the 1990 Mars 96 mission, which I mentioned, we had come up at the Planetary Society with the idea of sending a DVD to Mars with a library. And we started out by honoring 3 of our advisors at the Planetary Society, Isaac Asimov, Ray Bradbury, and Arthur Clarke, giants of science fiction. And in fact, for a while I was calling it the ABC mission, Asimov, Bradbury, Clarke. But then the idea grew into getting a whole library of books about Mars exploration, what inspired Mars exploration. And we did a joint venture with the Time Warner to create this DVD, which was placed onto the Mars 96 spacecraft, but the Mars 96 spacecraft was lost. But we still had our DVD. And so we just waited and waited and waited, and by 2006, American mission Phoenix was going to Mars, and their chief scientist was very amenable to carrying this DVD to Mars. So as part of the Phoenix mission, this DVD was taken to Mars. It's landed in the polar regions on Mars. It's there today as the first Martian library for whoever gets to Mars and can ultimately use it.
Is looking for something to do or read to pass the time.
Right.
So what's next regarding Mars? Where do we go from here?
Mars program in the U.S. is laced with uncertainty because our focus, Perseverance, of course, is up there doing wonderful things, collecting samples on the surface of Mars. We have several orbiters up there, but our focus has been on bringing back samples from Mars and a Mars sample return mission. But that mission has gone way over its planned budget, and there's a big debate now about what the future of that mission will be. It was hoped that it was going to launch in 2028. Then they slipped it to 2030, and now most recently they put the whole project on pause. Many of you heard JPL has had to cut back their workforce. They've laid off a lot of the people who are working on the Mars sample return mission, and they've gone back to the drawing board to try to figure out how to get a Mars sample back. And I'm not going to get diverted into too much discussion of that. Meanwhile, Europe has a Mars lander which was started out as a cooperative project with Russia, but then after the Ukraine war, the Europeans pulled out of the joint project and decided they'll do it alone, and they're with some NASA help, and they're planning to launch in 2028 or 2030. That's the Rosalind Franklin lander, and so that's probably what's next as far as getting to the Mars surface. And the Chinese are doing a really active program. They have a rover. They've had a Mars rover, and they're planning a Mars sample return of their own for 2030. They've just conducted a lunar sample return, which is ongoing right now, and so their program is where the activity is. And to me, there's a little bit of an analogy, which is we're kind of stuck on trying to figure out what we're doing in the U.S. Chinese have an active program. I think it's time for an initiative to figure out how to do it together, but that's even more politically difficult than the situation was in the 1980s with Soviet Union, and I'm too old to take it on.
So we have to look at somebody out in the audience or out there in internet land to take up the torch and make it happen.
But it should happen.
So I think we have a few minutes for some questions. I know we can get some from people who might be watching on the internet, as well as people here in the audience.
Right here.
Hi, Louis. Thank you for mentioning everything that's been happening with the Mars sample return. In fact, last year when you spoke here and you were talking about how it wouldn't be worth it to do Mars sample return if it wasn't looking for life, for example. So I keep thinking about that. But I'm curious about your thoughts, and the Mars sample stuff is part of it, your thoughts of how everything is switching from government to private, as we're seeing with all the space missions, and everything's kind of drifting away from JPL and things like that to private.
Yeah, that's, I got to be careful because I don't want to be a curmudgeon. That's what happens when you get older. It's not switching away in the areas of exploration. Private missions, they're doing great things. They're finding new ways of doing things. I admire greatly the innovation and the success of SpaceX. I admire what Jeff Bezos is doing. I admire a lot of these private developments, but they're not exploring. They're basically doing the kinds of missions that are in Earth orbit. Some of them are going to be for tourism, which is kind of worthy for tourists, but not for explorers. So I don't think there really is a shift away if we're going to do the kinds of things of searching for life on other worlds. I think we're a long way from doing that privately. We're not even successfully doing the private space science missions yet. So I'm not negative about it, but I don't think that's a panacea to be looking for the way to do things. My focus right now is, as hard as it is, I think we have to support the idea of trying to get the government missions. It would be greater if we could bring more international assets to bear and find ways that the private industry can contribute to lower the costs of them. That would certainly be helpful, but there's still going to be government missions carried on, is my view.
Question about asteroids and planetary defense. Some time ago, I heard there was a major effort to track and locate near-Earth objects that might hit us, and we'd mapped a stunning 90+% of what might be out there. But there's also a segment looking toward the sun where we can't see anything coming till
Right.
it's too late. How are we doing about knowing what the threat is and how prepared we might need to be to avoid
Well,
getting dinosaur extincted?
We're doing really good at cataloging a lot of the near-Earth asteroids, as you said, 90% even greater than that, and larger one. How we're doing at being able to find the ones that are hidden from us, actually, that's still a challenge, and there are people in the audience, including from the NEO Surveyor Project, who could probably tell you better than I can as to what's going on right now in terms of the development of space missions that can fill in those gaps at finding them. I don't know if they want to chime in or not.
Not about that, sorry, it was for a different question. How would you describe the challenges today with governments working together for human exploration of the solar system as opposed to country exploration of the solar system?
Could you be a little louder, please? I heard the human.
Better?
Yeah.
All right. How would you describe the challenges from working with the Soviet Union versus the challenges that would have to happen now for intergovernmental work to explore the solar system as humans as opposed to as countries?
The technical part of the challenges are no harder, I don't think. The political problems, I think, are harder. There has been a tendency, and certainly everybody knows this in terms of space powers, to, on the American side, to go it alone. Even when we were developing the Mars sample return, there was not much interest in building an international project. There was European contribution, but there was a secondary, it was a minor contribution. There's no interest in the U.S. in working with China, who is doing a Mars sample return. And any other contributions are minor. The U.S. view, which was built up, I think, over the last 20 years, with a certain degree of understanding, they were doing really well, and they thought they really had the support in the program to basically do it their way. So I think the political situation in some ways is harder, not because it's intrinsically harder, but because the impetus to do it that way. If you go into a NASA meeting and mention the word China, you'll be alone in the room in about a second. So I think that's it's more difficult.
I have a quick question for you. I'm just curious, are there any developments that you're aware of as far as propulsion systems that are not combustion-based that are using some next generation of propulsion for space travel?
Solar sail.
Okay.
There you go, the solar sail. That's what we call it. My friend Slava Turishev is also working on solar sail missions, and we see it as a low-cost way to propel spacecraft into the solar system without using fuel. It has the advantage of being low cost, but it also has the advantage of being very efficient because you're not having to carry propellant along. But you can't do large payloads. You can't do a human mission that way. You couldn't even do a Mars lander that way. It's limited to small spacecraft.
We have
by and
another
large.
question in the back of the room there.
Okay, great.
I think that'll be it. Or do we have two questions? We have another person back there too?
In terms of the solar sail, I was just wondering how fast would something like that be able to go? Would it be something like a FTL or?
It's a very low acceleration, very small acceleration. And but it can operate continuously, so you can build up speeds over a long time. In addition, technique that come up with basically is to, if you want to go out of the solar system fast, fly in toward the sun first. Pick up your speed as you get all that solar power from the sun, from the heavy sunlight, or the bright sunlight, the heavy force, and also from the do your velocity change at perihelion, where it's most efficient in order to get the orbital speed high. So you could go out of the solar system at speeds like 100 kilometers a second if you fly inward first and then go out. So it's probably the best way to go fast out that way. But it does take time to build up that speed, and you have to do it that way.
Thank you.
Well, is there another question back there?
I think we're good.
Okay. Well, I want to thank you, Lou, for coming here. It's been an honor to have someone of your caliber to be able to talk to and share your lifetime of knowledge. And hopefully it inspires some of the younger people here to carry on.
And it's an honor for me to speak to a group like this who really does some great personal adventures. Every time I hear it, it's so interesting and so fascinating. So thank you very much.
So thanks, everybody, for watching.